Today we are very happy to have Dr. Gang He, not Gan, Gang He, to be here. Dr. Gang He is an assistant professor in the Department of Technology and Society at Stony Brook University, as well as a visiting faculty affiliate with the Lawrence Berkeley National Lab. His research group focused on energy in many ways, like energy system modeling, energy and the environment, energy and climate, energy economics, and energy policy. Then I want to mention something more personal and more interesting. Dr. He and I, we were graduated from the same department in the same university, Peking University in Beijing, China. Before we both came to the US for further development, but he was several years ahead of me. Besides his research at faculty roles, he actually had a lot of interesting experiences. Some highlights, like being the founder of the first student association of climate change in Peking University. He was one of also the earliest mainland China student participant to the UN climate change conferences, UNFCCC conferences, as early as 2005, right? I think even before there is this definition of climate activist in China, he is already one, definitely. So it's also super interesting for me and for us to see how he transformed from a teenager activist to a professor in the US. Right, before we start, there is this announcement there, right? If you are interested to talk more with Professor He afterwards, we will have breakfast tomorrow at Aromas around 9 o'clock. So please feel free to join us. Several of you already registered, and we will come more, okay? All right, now the floor is yours.
Thank you, Yala.
I will help you to.
Thank you, Dr. Jin, for having me here, and it's a great pleasure to be here. This afternoon, when I walked across the campus, and Dr. Jin's introduction also bring me back to the good old days when I was in my college, and to see such beautiful smiling faces, so many of you, reminding me that small group of people, when you have a dream and you committed to do something and you are able to make something different, that's the value of being at the university, and that you really can able to make great things happen. I'm proud of some of the activities I did during my graduate years, but it's been quite a long time. So today, I'd like to take the opportunity to share some of my thoughts and integrate it with part of my research. By no means to give you a holistic picture about China or China's energy and environment. It's just my personal, maybe biased view, and I hope that can help us to have a more conversation rather than just me lecture you something. So feel free to ask questions. I may push you to some questions, so raise your hand if you want to give a try. Do not be shy. I hope we can enjoy this 1.5 hours. Okay. How many of you actually been to China ever been to China? Okay, many of you. That's great. Anyone from China in the student body? Great. So when I try to capture some of the ideas, as you see from the title of this talk, you always feel puzzling that see from the left and see from the right, and both happening at the same time. I'll explain a little bit, start from the picture, this one. So that's a larger screen with blue sky and beautiful clouds, clean air. At the center of the Tiananmen Square, and very iconic. And it's during the springtime, and so you can see that clean air is part of the Chinese dream, right? But that dream at that moment only happened on screen. So that's one. But at the same time, you see from the other side, that's one of the beautiful moment of China's ambitious in building the world solar panel as cute as a panda. The actual picture may not see as nice as this one in the field, but it's just quite make the clean energy cool, right? And this one, I took this one. I visited one of the largest coal mine in Mongolia. In Mongolia, and this one is very important because the coal from Inner Mongolia, probably when you see, we enjoy electricity, we don't care where the coal come from, but coal it literally comes from, China's university electricity actually come from the coal from there at the center of the Inner Mongolia, the Black Triangle. And I visited one of the mines. One of the dramatic things is to see, I see miles of trucks transport coal from the coal mine, the pit mouth, to where the coal can transport to through the train in the transfer station. And some of the coal do not able to get the capacity of the railway. They have to transport by trucks. And the trucks has many problems. They are loud, they destroy the roads, and they also pollute the air. But that's part of the lifeblood of China's economy. And you can see it's there. And the other side is one of the largest and the oldest wind farm in Xinjiang. So you can see, these two sides of the pictures really give you some dramatic scene of what's happening in China. And this one, it represented the old dynasty, but it had some optimistic feeling that, coal power plant, they need water for cooling. But this one using the up-to-date technology of cooling the coal plants by air. So this giant cooling tower, you can see this is all small pieces of to help the air flow, so it cool the power plant down. That significantly reduce the water footprint of a coal power plant, and it's also happening. This one is more personal. I was born in central China, small village, and even my hometown using solar panel as a street light. So you can see in 2015, China actually achieved the milestone that 100% of its population have access to electricity. Given the world still have about 1 billion people do not have access to electricity, it's quite an achievement. So overall, I spent a few minutes to introduce the picture. This is just a tiny bit of the big iceberg. So you see this from news, from different media, that both are happening in China. So why, right? First, so this is one side of the picture. Okay, you see this a lot. China burns half of the world coal consumption. That's huge. Half of the coal, and 45% of that is burned in all kinds of coal power plants. At the same time, also on the news, And this picture is quite average. You see, it's highlighted those areas that China is not the number one, and which means that our other places, China is lead with the world largest wind solar installer. China need the development of hydropower, and also China is the largest solar water heating installer. And those who are China not lead is mostly by per capita standards. That means because China has huge population. So when you see this, we have very, dirty coal combustion, and China rely on coal for its primary energy. But at the same time, China lead on the clean energy revolution by putting state capital, the incentives and the motivation to build the world's largest fleet of renewable energy. And what's behind those? And how do we digest those news? That's, I hope to, at the first half of the talk, I hope to, engage you to think together why and how we understand all this. I'll give you a few seconds to think about it. And maybe some of you can share your answer when you see such news. Why, right? Well, I do not have an answer, but there's a way to approach it. How many of you have ever seen this formula? Thank you. So if we think about the impact, this impact can be the impact to our air quality, or the impact to the global warming or climate change, right? Emissions of carbon. It's a function of population. That's don't need to explain. Affluence. When rich people, they consume more, and that has a energy footprint, carbon footprint, water footprint, or the material involved in the rich style of living. And the technology. This technology is, the more we use those larger scale technology, the more impact we created to the earth or the natural environment. And if you really think about the area that do not have human footprint, is really shrinking. So this formula, created first by John Hodgson, and getting quite aware or commonly explained and approached in the energy environment community, it provided a way to think about, let's say, China's problem or an opportunity, right? China has 1.4 billion population, and it's recently reached that 1.4, and which almost 1 in 5 people on the world is living in China. And that has big implications. As former Premier Wen mentioned, he has a formula, right? If we have a pool of resources, and if you divide it by 1.4 billion population, everyone only get a slight, tiny bite of that. But if everyone have a small problem, you add together this 1.4 billion people, then you got a big problem. As you can see in the energy environment field, or more recently, maybe the coronavirus. And urbanization. China is in the process of fast urbanization. The scale, I want to use a metaphor that now China has 1.4 billion people. US has about 300 million. So that's about China's 4 times the size of US. And over the past 30 years, China moves about the size of a US population from rural China to urban China. So that's the scale. And in the coming 20 to 30 years, another US-sized population will be moved from rural China to urban China. And that all has implications of how we consume energy and how we protect the environment. On average, people living in urban land consumes about 3 times more energy than people living in the rural area. Industrialization, we all know, probably your clothes, your shoes might be made in China. So industrialization or the manufacturing in China has implications that goods manufactured in China, pollution left in China, but the goods are consumed in the West, in the world, in the whole world. So who should take the responsibility for this pollution? You may debate that, or China benefit from doing that, but who is really consuming it? And the consumer's responsibility in protecting our environment. And that's really bring into our conversation. Lifestyle, if you live in US, you know this. If everybody wants to live in US lifestyle, probably we need 7 or even more Earths to support that. So, but you cannot stop people from, pursuing happier life, right? But it's not necessarily materialized life. And how we change people's lifestyle and the consumer's behavior, that's really needed into the discussion. And the argument again is the international trade, that it's not the trade for goods and money or capital, it's also a trade of clean water, clean energy, and they are embedded in these goods, and we need to take into account of that. So if you think over this, and you really have a sense of why the problem or the challenge, the crisis, or you can say energy crisis or environmental crisis happening in China, and it has a global implications, because we all consuming the made in China goods, right? And what we can do to help, and everybody can help. Another I hope to message or big picture is China's energy or environmental crisis or challenge is embedded in China's overall economic transformation. I mentioned this, the scale is unprecedented. It's historical in the human history. Such a big country, a big population getting rich and getting urbanized and going to outside world. Okay? And also especially within China, we have 3 worlds. It's like we have cities like Beijing, Shanghai. It's more like the Western world, and we have villages. My village is lucky to get the solar panel, but there are many other villages who don't. So spatial, temporal, both are quite persistent. And the scope is not just when we talk about the scope is, so US or other Western challenges is accumulated through 300 years of industrialization. So, but for China, it happened in about 30 to 40 years. So when we have the same challenge, and when you condense in such a short time period in human history, you just think about the scale. It's there, and also the scope. It's not just about one component of the environment. It's the whole system, environmental system, or you can say ecosystem. Air, water, soil, pollution, it's all happening together in the process. But the Chinese word of crisis and opportunity actually is combined in one word, which is 危机, as you probably know. It's also presented the opportunity, because that's why you see those exciting things happening, right? Clean energy presents the opportunity that China can compete with other countries at the same starting line in this area. And because of China's scale, and it can motivate the resources to build the technology and implement it at the scale to bring down the cost significantly to make it competitive. And that's the contribution and the opportunity for China and for the outside world to work together, really help China at the same time, help the world to achieve a larger scale deployment of the clean energy as we can see here. So that's brings us back to when we see this challenge, how, right? We will discuss a little bit more about the APAT formula, but slightly different way. We know the impact still has relationship with the population. While control population is controversial and it's not the option, or it's not in the mainstream discussion. And affluence still, people has the right to living a better life, and it still has impact. But can we move the technology from the impact side to the, help us to address this question? As we have had a very good dinner conversation with Dr. Maniaki and also Dr. Harish. So technology really can be a solution in the sense that can we do more distributed? Can we do more soft technology, as we can see, which has more resilient to the environment, to the climate change, at the same time to address the problems that the larger scale or the soft path technologies usually create. So technology, can we move the technology from the fraction to the denominator side? Okay. And policy can really help. I'll use one example to explain it at a later session, but policy, regulation, and appropriate management of our resources and the environment can help us to address those questions. That's policy and management. I talked about lifestyle, consumer behavior. While consumer behavior really can be a driver, because you or we are leading the direction that what products companies should produce and what products can be accepted in a market. And that really has the power to change what products and how the products are produced. So the behavior side of this formula is really can be a driver in solve those challenges. And all the exciting developments in this area provide the opportunity for us to doing research or go into the market to act as an entrepreneur and create the business opportunity, and not just save our environment, also help the community. And that's the larger picture. I hope we can create some common ground for discussion. Now I'll try to use some of my own research to address. So what about this to do with energy, right? I mentioned coal dominates China's energy mix, but can you think about why? So why China consumes this much coal? Of the history of big chunk, about 60% of the primary energy is coming from coal. If you talk about the electricity, about 67 to 70% of the electricity come from coal. And even coal is plateau, still China consumes a lot of coal. So why? So easy access. Okay, what's your name? Claire. Thank you, Claire. Any other thoughts? Can you speak louder? You mean resources, massive resources? Yes, because China is the third, with the third largest reserve, more than 150 billion tons of coal. If you think about the scale of China building, consume about 3 billion. The units is can be misleading because this is tons of oil equivalent, because different energies they have to compare each other. So oil is like the currency, so they use oil convert. So it's the conversion between oil and coal. So 1 tons of oil equivalent is about 1.4 a coal equivalent, and the coal equivalent still because you have different quality of coal. So oil equivalent is the standard coal that has about 7,000 calorie of heat content. So that's another story to explain a little bit. But the reserve China has really provided the energy security. So if you think about energy, a national energy strategy, you kind of try to balance the availability, the costs, and the environmental climate impact. And this triangle, in some sense, they call it impossible triangle. You cannot achieve all those goals without sacrifice one. So while China has the reserve to provide the energy security, it sacrifices the other two directional. Exactly, coal is cheap, it's widely available, and it's easy to use, and it's provided the safe ground for China's energy security. But it creates a problem, right? Coal contribute to the air pollution, the particular matters, as you can see from the very first picture we saw from the start. And also, it's created all other related questions like climate change. If you think about where the carbon comes from, coal is the main sources. And in addition to that, coal also has the social justice problem, which I will talk later. So that's why we have to think about enabling a rapid and just coal transition, especially for China, because how China burn its coal will have an impact how China and the world to achieve its global climate mitigation goals. Without the significant reduction of coal consumption, there's less opportunity for the world to deliver the Paris Agreement, the 2 degree or 1.5 degree temperature control goals. But it has its challenge. And why we add a just coal transition there? Because coal also has people, right? In some area, especially in Shanxi and this black triangle area, Shanxi, and in the Mongolia, coal is not just seen as a source of their economy, a backbone of the economy, but also it's kind of their identity. Think about these coal workers, they're working for those coal mines for their whole life. So their lives there. And it's people's life. How, if we transit from coal, transit away from coal, where those people get their next job, how we help them, help the community. This is all real question. It's not just for China, it's also here in the United States and other coal-consuming countries. So from this picture, you can see energy consumption keep going, GDP growing very fast, which is the orange line. GDP goes faster than the energy, which means China's energy intensity is getting better. And good news is coal consumption first going very fast up and then plateaued at since 2013-ish, and that's good news. But it's still at a very high level. So the challenge is how we bend the curve, and bring it back to the level that if we want to achieve the Paris Agreement compatible goal, and we need significantly reduce the coal consumption to nearly 0% of the energy as share of the primary energy by 2050. So think about the different trajectories that we can achieve it. And here are some milestones that Chinese government try to push in that trajectory to reduce coal, to promote renewable energy, but it may not come from the energy consideration. It's rather from air pollution, from environmental considerations. So here in 2005, China introduced a renewable energy law, and then 2013, China introduced the action plan on prevention and control of air pollution, which defines the standards of coal power plants, and also try to set up a goal for what the maximum concentration of pollutants in major cities. And that's really created the incentive for local governments to take actions on that. And a coal-fired power plant, energy saving and emission reduction, which really move. First, it's introduced, if you want to build a new power plant, what's the minimum standards? And second, how to retrofit the existing fleet in order to meet the minimum standard. And the minimum standard is compared to those emissions from equivalent gas plants. So that we know natural gas is much cleaner than coal. So they were trying to set up the standards to, if you want to burn coal, you should burn it as clean as a gas plants. So that's quite a measurement to how to improve the technology in order to achieve those goals. And energy production and consumption revolution, which really to bring up the idea of energy revolution in order to accelerate the process of clean energy development. So there are challenges. I mentioned briefly, some, but here is, let's say, what's the message here is this is new additional capacity by technology in each year. So you can see starting from about 2005, China building a lot capacity, including coal, hydro, and renewables, increasingly more renewables. So that's good. But at the same time, the large capacity of a coal, they are building since 2005. So this picture describes exactly that, which means that in 2000, year 2000, and about half of the capacity or the coal capacity is within 5 years old, which means that those, if we look at today, and more than half of the coal capacity is less than 10 years. A typical coal plants can run as long as 30 to 40 years, which means those existing capacity, which is pretty new, and they will keep running for next 20 to 30 years. And if we cannot create incentives for those plants, that would create a stranded assets problem. And it's the real challenge. Here in the United States, if they reach the retirement age, you just let them retire. But here for China, those are new plants, and you have to think a way to how to keep this run or how to retire them from before their retirement age. But there are drivers to help them to help this process. And here, this actually comes from a paper that we are working with my collaborators to see how can we really think about to speed up the process to phasing out the coal. One of the ideas is we can think about the benefits, especially think about the impact to water consumption, the impact to reducing the mortality, the premature deaths due to coal consumption created air pollution or environmental pollutants, and the job loss from how we deal with the just transition challenges. So each line represents different pathways from the top institutions, what their projection of a future coal consumption in this chart. And related to that is their trajectory of carbon emissions. Some in the most aggressive trajectory, they are achieving the long-term carbon reduction goal, like 1.5 degree or 2 degree goals. And the up end is more about the business as usual, which you can keep burning more coal and you still polluting, keep polluting the environment. So the differences here is if you move to the more aggressive coal phasing out trajectory, you create opportunities to save more water, save more life, and that co-benefits really justify the transition. And as you can see here, this rough numbers that you can think about the scale, different trajectory, their coal consumption by 2050 can as big as 2 billion tons of a coal equivalent. And that would translate 10 billion tons of difference in the carbon emission and 5 billion cubic meters of water consumption, because you need water to cooling those power plants and you need water to extract coal from the ground. Premature deaths, you can save as much as 220,000 people from premature deaths if you consuming less. If we move the trajectory to the more Paris Agreement compatible trajectory. And we lose the code jobs anyway because they introduce more productive mechanics in the code extraction. But compared to the highest in about 2010, about 5 million co-workers would lose their job. And how we create the right policy and the incentives to help them to transit, that's really the challenge we have to think about from today, because we cannot wait until it's happening, but we cannot wait until 2050 to address those questions. For sure, we propose some large strategies or ideas such as create a energy or coal transition commission or task force to coordinate the different stakeholders to address those challenges and put an agenda to set up long-term coal phasing out goals, just like China did for its short-term goal, but China do not yet have a long-term goal for 2050. And those goals can create a clear message that this would happen, and it would mobilize the resources and the market response to the long-term targets. We also discussed how the network we can use in order to help the people who suffer from this process, and the environmental restoration idea that because the skill sets can be quite similar as extracting coal as the coal miners. So to use their skill sets, but to more work on the environmental restoration, and that created the so-called double dividends. So you help them and also make use of their skill sets for social good. So this is the employment different region, and you can see those coal-rich provinces really have heavy share about the overall coal jobs. And as you can see here, coal jobs is not just in the coal mining business or coal washing business, it's also in the coal power plants. So we need to think about the regional and differentiations of within this context and the different along the value chain. And this is very important for us to understand how this just transition can happen in a more smooth way. So talking about the coal, that's more about phasing out the dirty fuel. But also at the same time, we have to find the alternatives, right? How to drive the rapid deployment of clean energy at the scale needed. There is a reason why coal is seen as a default fuel in China. So how we create the drivers to fill the gap that when coal phasing out, if not, then it's hard to happen, right? So we have to think about, if not a coal, what, right? This type of a question. So from my own research, this is about what are the drivers of a clean energy transition. Here I'll use a few examples. I know time is running out. So some is about resources. I hope this, from my limited experiences, that hope you can give you a test of what we can do. And I hope to share that there are exciting research opportunities in this area that I hope that can inspire you to do more work in this field and help us to think about the big questions and be part of the community to help to make our world a better place. So think about the resources. We have to know where to essentially ask the questions, where and how much of those resources are available. Why they are important? We know we discussed the advantage of using coal, but that's related to the question of the renewables. They are variable resources. They change when the sun come. You have the renewable, but when the sun comes, and wind can come and go, right? So those are the challenges. So essentially, we need to understand where, when, and how much those renewable sources are available. This has to do with resources, and with the modeling, simulation, and with the data, you can think of what the scale of the data, especially enabled by the increasingly available big data and other resources that you can use. This provides a rich resource that you can use for a better resource assessment that can help us to understand how we can better integrate those variable renewable sources in order to make up the gap created by phasing out the coal. Other examples is how we can use the model to provide evidence-based discussion, because very often we know policy and management and regulation really can make the differences. But how research can help is, can you provide more evidence-based policy recommendation? And that has to do with some of the techniques that where model can help. While people may say all models are wrong, but some are useful. So we are not trying to create a perfect model that people can rely on. But this model can create the thought experiment to help understand what if we do this, what are the consequences. So that creates some foundations for these evidence-based recommendations in our discussion. So while I do not want to dig into the formulas of this model, it creates where the what infrastructures, and the model can really help us to understand what instructions, because we know the resources has temporarily variable and spatially imbalanced. It's mostly in China's case, the resources are mostly in the western and the northern side of the country, while the demand center is along the eastern coast. So you need to build the transmission that those are critical infrastructure that can help us to enable the clean energy transition. This is the message that I hope I can help communicate. Another driver is the cost. It's amazing that over the past 10 years, the cost of wind has coming down about to 50% than 10 years ago. And for solar and storage, it's coming even cheaper, which is about 80 to 85%, coming down 85% as compared to 10 years ago. So this provides some optimism that we can do better than we do it today. We use the model to show that the projection in the mainstream research institution that this is a flagship report by International Energy Agency. Each year they publish a World Energy Outlook, and they project the deployment of solar PV. And you can see they keep moving up, but the reality always exceeds their projection. So one side behind that is the market is really fascinating, and you see from what's happening in the market, the cost is getting cheaper and cheaper, partially due to China's larger scale of deployment of renewables. So how big that impact to the power system? As you can see here, we did that for different scenarios. The business as usual is the conventional projection of the cost, and R is the renewable scenario. What if we have the cheap renewable? You can see by 2030 we can do a lot more renewables than we envisioned in the conventional discussion. That offer the optimism that we can do better than we do today. And that's where we should motivate the resources to. Why is it important? Because the power sector or the infrastructure really has the implications. Once you put out there, it's there, and it will be there for quite a long time. So in order to avoid that lock-in effect, the investment decisions today would have long-term impact for quite long periods. Okay? So that's why the investment decisions really can needed to address those challenges, and that's where a model or evidence-based research can contribute in the policy conversation. One last idea, or it's where the policy can really, we discussed the policy. As I mentioned, in 2015, China achieved electricity for all its population. And while this is quite impressive, as we discussed the scale, but at the same time, so why it's difficult? So here I can see from the cost, when you provide electricity to the last mile population, it's getting a lot expensive. As you can see, different years, because they are reaching the last mile, and the average cost of those population to provide electricity to those population is about four to five times compared to those normal situation, because those people who do not have electricity, they live in the remote, adverse environment, that in order to provide electricity, either through grid access or through more distributed solutions, all make it much difficult, much expensive. So that really has to mobilize the policy and the resources in order to provide electricity to the last mile, to address the last mile problem. So the lessons known from, or the experiences known from China's case is really need to align the central government and local government interests in order to say, while the central government provides the resources, it can be investment, capital investment, subsidies, and the local government work together to really work on the implementation. And these two can work together to address this very important issue. And also to really choose the appropriate technology. The difference between the grid access technology or the distributed technology, you have to carefully calibrate it. So where you use grid access, which provide reliable service, but at about a little bit higher price, or you choose distributed energy, you have to calibrate it. So that's where engineering and can really work together with the social scientists to how to change their behavior, to accept those benefits. And electricity is really fundamental to all other services. education, communication, access to information, access to clean water, access to the healthcare, and that's where providing electricity is really benefit the community and the population to help them to access all this modern life convenience. So policy can really make a difference here to help those who need the electricity most to have access to the energy. Growing this clean energy transition also driven by the constraints, as we discussed, air pollution and water stress. Where you generate electricity is also where you are lack of water. You have water stress. So those drivers, a lot of conventionally discussed, created a new research field in so-called food, water, energy nexus. And that's where the interdisciplinary communities, just like you, can really help in the conversation and define how different systems can work together in order to address the complicated challenges along this energy transition. I have about 5 minutes to summary what I have discussed. So China's energy transition, because of its scale, its scope, really embedded in the economy, energy, and the environment. This great, larger, bigger picture. When we think about China's energy, we have to think about in this larger transformation. And when we think about to achieve future transition, or electricity is really under the center for two reasons. First, when we think about transition or achieving the goal, we have to decarbonize our energy system, right? So if we think about to first electrify our energy system and then decarbonize it, we kind of approaching in the right direction, right? But for sure, we have sectors that are not easily to replace or transferred by electricity. For example, in the transport sector, or especially in the air transportation sector, it's very hard to use electricity to replace all those fuel. But still, electrification is one of the fundamental ideas behind this. And when we think about all these drivers, resources, costs, new constraints such as water, air pollution, when we think about this, its policy really have very strong impact in order to enable different resources to work together. And that's where the policy or the model or evidence-based research can really provide the support needed by the policymaker in order to make this transition in a fast and just way. And that's where the data-driven or the model can really make some contributions into the discussion. So I'll stop here and to create more opportunities for us to discuss. And please feel free to ask any questions you may have. I hope if you come after this, you have more questions than you first came here. That's the goal. So I would be very happy to see that. Yeah. Thank you. I want to acknowledge all my collaborators and thank you. So maybe I should put this picture here. So I just share my part, so please be aware of that. Any questions?
I have a question actually. Right, you mentioned there are a lot of policy changes and it's always changing rapidly in China. How would a modeler be like quick enough to really model those policy changes in the models? I've been thinking that for quite a long time. Every time I have a working paper, the scenarios will be quite different when it is forthcoming in the journal. So that is tricky thing.
Yeah, thank you for the question. That's really the challenges. And you probably hear the joke, if you are not in China for a month, if not 2 weeks, you are no longer a China expert anymore because things happen so fast. My ideas on that is you try to capture what's the drivers that I mentioned here. No matter what policy you are discussing, they have to rely on those drivers to make the policy work. So if you focus on those drivers rather than the specific policy itself, that create some fundamental, because in the end, you want to understand how specific drivers can lead those consequences. And that way, it would be adaptable to the new policy that because you have so much toolboxes and you can assemble this together, and no matter what policy you are discussing, you are using those toolboxes to describe or provide the analytic framework to their consideration, and that usually helps. But still, I cannot say the challenge is still there, and we acknowledge that. Please.
I'm curious, politically, what's driving this transition? Is it public pressure, sort of bottom up? Is it top down from the party? And what sort of challenges or opportunities does China's political system create in this situation?
While we have more political scientists here, they may be in a better position to answer your question. I'd like to share my personal observation. So I think it's drive from both direction. While more top down is where it reaches a point to a consensus is reached, and the idea leads to deployment at a larger scale. That's where top-down can really make a difference, and that sometimes people may think China has the advantage to do that. But at the same time, the bottom-up is really important especially in the energy environment community. You probably hear about a movie, Under the Dome. The idea is people under the dome with all the air pollution. That's a very dramatic movie. It captures how people's life in the air, live in the urban cities with severe air pollution, and why people still living in such situation. It creates such a sentiment of people's unhappy about that, or people want to make a change, or people want to contribute into the discussion, and that creates a huge pressure to the government to respond to the demand from the bottom up. So that's, I think, is one of the examples of how the bottom up forces can really set up the agenda to let the top-down approach can work in the right direction, and it's both sides, I think, are very important to address.
Is recorded?
Okay. Thanks so much for the talk. Very fascinating. What's interesting to me is going on this political line, that you're creating models that are helpful to informing policy, data-driven approaches, etc. Sometimes I get the sense in the U.S. that experts, regardless of what they say, there's not a lot of interest in what they have. to give us, because there's other economic or political reasons why policy is going to go one way or another. So just your impression in comparing, obviously you're in the US, you have experience in China, comparing the two systems. Is there a different rate at which experts are listened to? Is this type of research, if you did the same study for the US, would it just be in a journal and have no policy impact? Or is this study just going to be in a journal and have no policy impact as well?
That's challenging. Even for me, so we have to find the approach to impact the policy, no matter in the United States or in China, that you need to always find the right, at least I feel, the right person to talk to, who are in the policy community, who can make the decision, or who at least who are involved in the process to make a decision. And that's the key to engage the community. Here in the United States, I feel it's more open and engaged process. Like you can go to do a public hearing to testify your research or your finding, your opinion. While in China, you probably to work with the people who are in the community and to inform your research and to engage in their conversation and try to set up in the process to set up agenda. That's slightly different, but in both cases, I feel still need to identify the approach that you can join or engage in the conversation, which for sure I needed to do more on that. Yeah. Please.
Please wait for the microphone.
Yeah, sure.
Thank you for coming and speaking today. I was just curious. I was looking at a lot of the tables that were provided in the research papers, and some of the charts that you had put here. There's a lot of trend going forward that energy consumption in China is going to continue to go up. Industrialization will continue to go up. Access to power will continue to go up. And that's going to require quite a bit of increased energy production. Some of the wind projections require providing 9 times as much energy from wind in the next 15 years. 50% again more in the 15 years after that. Electrification of vehicles would require a lot more draw on the grid, and simultaneously cost of power is going down. So I'm just curious where a lot of the funding is coming from going into the next 30 years as production goes up and costs come down.
Yeah, there are multiple layers of your question I hope to discuss. First, it's the projection of future energy demand. That itself is a fascinating research area because there are many uncertainties on that. But in general, we kind of focus on the energy efficiency that create where it can really make a difference. And from what I understand, the different scenarios where you have energy efficiency or not can make a difference as much as 5,000 terawatt hour. I didn't work out the conversion by 2050. That's quite a lot, almost 20 to 30% of the total electricity consumption by 2050. So that first is create a huge space that the system can improve. If we do more energy efficiency, we don't need that much new capacity, new generation, for example. And second, building on that, so how we organize our resources to achieve those targets or to fill the energy demand with the condition that we're facing on the coal. So that's where we say every all technology counts, and different technology can contribute to the pie. Especially for China, there's a nuclear has a big role. And when I do the model, I see nuclear is the most the sensitivity to. If we have nuclear, we would the system would work much better than reliable than a system without nuclear, because nuclear can run at a high capacity factor, can run most of the time. It's reliable, and it's carbon free. If you talk about life cycle, maybe, but it's still compared to coal and fossil fuel, it's very little carbon footprint, and it also other resources like wind, solar, and hydro is also a bigger portion of it comes out. If you add all this together, then you look at the renewables, then you don't have the scale that you may imagine to fill those gaps, because renewable has its own limitation. Is in order, because solar wind, they're only available few hours, right? So that makes it the capacity factor is very low. That only a few hours you can producing electricity. That you need more capacity in order to create that energy you need. So that's where you can see the differences is energy efficiency and more other carbon-free technologies, and together with renewables. And our cost research paper, the main finding from that is storage can really make a lot of the difference in order to manage more renewables. The way how we do technology, the storage is partially by 2030, for example, China would have more than 120 gigawatt of pumped hydro storage online. So that creates a huge pool of storage resources that can help balance what the challenge you raised. And for sure we need battery storage, and that need to work together with all the electric vehicles that rely on battery storage too. And if we talk about battery storage, the life cycle of now we are just talking about the storage, but after it reaches its life cycle, who is going to recycle, and how we you make use of those resources or the waste from it, it's all quite challenging. So we need everything. Everything can happen, but the last thing is easy. So that's where our research opportunities are. Yeah. Thank you. I hope I answered or partially answer your question.
Maybe one last question?
So last question can be a hard question.
Thanks for coming again. Okay. So I'm from the Philippines, and there's a lot of congestion with the South China Sea, and China has been expanding there to I guess gain control of some of the oil reserves. Is that part of China's green transition, is to expand out or seek new areas of oil and natural gas?
So part of the transition we are talking about is now you probably hear about China's building the road belt initiative or Belt Road Initiative, BRI. So that is provided the fundamental infrastructure to help, or at least to collaborate with involving countries to create win-win solutions, not just in the infrastructure, but also in energy and environmental area. But at the same time, we also pay attention to that. Is China investing more coal or more fossil technologies or energy, or renewables. So we have to pay attention to that. And if China is building more fossil outside of the country, then we have to take that accountable in order to, you cannot say China achieved the transition, but facing other coal to other countries. That's not what the world needs. So those subsidies to the fossil fuel industry or the state capital flow into this has to pay attention to, and we need to watch and advocate for the green transition as we did, not just domestically, but also outside the country.
Alright, so thank you for this fascinating first lecture, and let's applaud for Dr.
Thank you all for coming.